All right, that was number 6. Let's look at 7. It says determine whether each molecule is polar or non-polar. And then I have 4 of these guys. So I have XEF2, I have PBr3, I have CH2Cl2, I have H2S. Okay, so how do you figure out whether or not they're polar or non-polar? Well, I have to look at these guys in terms of Vesper theory, right? So I have XeF2 here. So xenon's going to go here, and have fluorine on this side and fluorine on this side. And what it's going to do is actually going to share electrons to this guy here. So what we can do is we can actually look at we can look at the geometry of this guy here. So what they're doing here is we can use Vesper theory, and this is what they're saying here, and we can actually look at the Lewis dot structure, which will give us the geometry of the compound here. In this case here, XeF2 is going to be a linear structure, right? Because again, the dipole on fluorine is going to cancel with the dipole on fluorine as well, because this dipole here and this dipole here is going to cancel out. So I'm going to get a linear compound here. So this is going to be linear. And then xenon has a full set as well. So again, in this case here, this would be trigonal bipyramidal, because I have lone pairs on xenon. So I have 1, 2, 3, 4, and 5, 6. But the electronegativity, but we don't really care about the geometry more so. We care about the polarity of the compound, right? And again, because the dipoles on fluorine cancel out, this is going to be a non-polar compound. So don't mix that up between geometry and polarity. Geometry helps us figure out polarity, but it's not necessarily the polarity as well. So for B here, we have PBr3. So we have this guy here. And again, we have bromine and phosphorus here. So let's look at what they're doing here. So they also drew a Lewis structure as well. Or actually, no, this is PBr5. Sorry, this is PBr5. So let me redraw this. So another Br as well. And again, if you look at Vesper theory, this will give us a phosphorus here is not going to have any lone pairs here, because it's all participation in bonding. So therefore, all these dipoles all cancel out. So therefore, this structure is also nonpolar. If you look at Vesper theory, you can actually figure out or Vesper chart. You can figure out the geometry of this structure here. So the first guy here was trigonal bipyramidal, because you had 3 lone pairs. So this one would have been this guy, trigonal bipyramid. And then for PBr5, you can say that this guy is trigonal bipyramidal as well, because you have AX5 here and there's no lone pairs. So this would be also a nonpolar compound. So next you have CHCl2. So this is going to be bonded to H, this is bonded to H, this is bonded to Cl, and this is bonded to Cl. You have an electronegativity difference between chlorine and carbon in this case. So this structure is polar. And H2S is also polar as well, right? Because you have an electronegativity difference between sulfur and hydrogen here. So to actually make the compounds polar as well. So again, you have polar here, and this is also polar. So this solution is correct. And again, you just have to look back at Vesper theory, look at the lone pairs, and look at, okay, are my dipoles cancel out or not? And if they do, then the structure is nonpolar. But if they don't, like in cases 3 and 4, then the molecule is going to be polar. So the solution is correct.